the last class we have discussed about the case of here the properties of elements, right? So now moving on to the next topic, that is the organic chemistry. So here in this particular case, in case of your organic chemistry, so we'll be discussing about the fundamentals that are related to the organic chemistry. So what are the compounds that we are using in day-to-day life? What are the compounds? So the moment you're talking about the case of your compounds, here we are specifically discussing about the case of your organic compounds. The organic compounds that we are using in the day-to-day life. So the moment you talk about the case of your organic compounds.
ఇలాంటి మరిన్ని వీడియోల కోసం ఇప్పుడే డౌన్లోడ్ చేయండి ప్లాటో ఆన్లైన్ యాప్. యాప్ లింక్ కోసం డిస్క్రిప్షన్ లో చూడండి. ప్లాటో ఆన్లైన్ యాప్ మీ విజయానికి మీకు తోడుగా.
Now these particular organic compounds in general they are also referred as hydrocarbons. Organic compounds in general they are also referred as hydrocarbons. So why we are calling them as hydrocarbons? The reason for terming these particular organic compounds, the reason for naming these particular organic compounds even as hydrocarbons is that these particular compounds they consist of 85% of carbon. They consist of 85% carbon. At the same time, they consist of 14% of hydrogen. 14% of hydrogen. Now, since they consist of 85% carbon, 14% of hydrogen, at the same time, the remaining 1%, this particular 1%, it consists of oxygen, nitrogen, and sulfur in small ratios or else in small proportions. Now, since it is consisting of 85% carbon and 14% hydrogen, they are termed as hydrocarbons. They are termed as hydrocarbons.
ఇలాంటి మరిన్ని వీడియోల కోసం ఇప్పుడే డౌన్లోడ్ చేయండి ప్లాటో ఆన్లైన్ యాప్. యాప్ లింక్ కోసం డిస్క్రిప్షన్ లో చూడండి. ప్లాటో ఆన్లైన్ యాప్ మీ విజయానికి మీకు తోడుగా.
Now these particular organic compounds, the moment you talk about the case of here the classification of these particular organic compounds, right? These particular organic compounds you further classify them into various types. So organic compounds are classified into various types depending upon the bond that is present between them, depending upon the structure of that particular one. So based upon these things you classify them, right? So in general, whenever you're talking about the case of your organic compounds in a very, very broader sense, of course, so the moment you're talking about the case of your classification of organic compounds in the broader sense, you're talking about the case of your MSET examination or as the case of your NEET or any higher examination. But here, we are restricting our particular discussion only to those particular compounds which we are using in the day-to-day life. At the same time, the fundamentals of the organic chemistry, the fundamentals of organic chemistry. So the moment you're talking about the case of your organic compounds, in general we classify them into two different things. One is the saturated hydrocarbons, right? At the same time, the other classification, saturated hydrocarbons, or else you even say unsaturated hydrocarbons, saturated as well as unsaturated hydrocarbons. Now the moment you're talking about these particular unsaturated hydrocarbons, they are further classified into two different things. One is alkenes, and the other one alkynes, and the other one is alkynes. So saturated hydrocarbons, we have got only one particular category. That is what is known as alkenes. Right. So this particular classification of the organic compounds into saturated as well as unsaturated is based upon the type of the bond that is present between them. Is based on the presence of the bond. So whether the bond that is present between them, whether the bond that is present between the carbons here in this particular case, that is either a single bond, or else the case of a particular double bond in case of your alkenes, or else the case of your triple bond in case of alkynes. So depending upon the type of the bond that is present, whether it is a single bond, if at all the bond is a single bond, then you call that one as an alkene. If it is a double bond, then you call it as an alkene. If it is a triple bond, we call it as alkyne, right? So any particular hydrocarbon which is consisting of a single bond, we call it as an alkene. If it is a double bond, if it is a double bond, we call it as an alkene. If it is a triple bond, then in that particular case we call that one as an alkyne. But the question arises here: what is a single bond? What is a double bond? What is a triple bond? How these particular single, double and triple bonds are formed between the atoms? So whether it is a case of your carbon, or whether it is a case of your any particular atom. So what is the reason, or else how these particular bonds are formed? Now the moment you're talking about the case of your single bond. Now for example, the moment you take the case of fluorine, for example, you take the case of your fluorine.
ఇలాంటి మరిన్ని వీడియోల కోసం ఇప్పుడే డౌన్లోడ్ చేయండి ప్లాటో ఆన్లైన్ యాప్ లింక్ కోసం డిస్క్రిప్షన్ లో చూడండి. ప్లాటో ఆన్లైన్ యాప్ మీ విజయానికి మీకు తోడుగా.
So in case of your fluorine, the atomic number of fluorine is 9. At the same time, its electronic configuration is 1s2, 2s2, at the same time 2p5. The outermost orbit of fluorine is having 7 electrons, and it is short of 1 electron. It is short of 1 electron. Right. So in order to have the octet configuration, fluorine requires one more electron. That is the reason why fluorine will try to form a bond with one more fluorine. So here in this particular case, here you have got fluorine. So this particular fluorine is having 7 electrons in the outermost orbit. So it is having 7 electrons in the outermost orbit. And this particular fluorine is trying to form a bond with one more fluorine. Even this particular fluorine is having 7 electrons in the outermost orbit. So here in this particular case, a bond is formed between the two fluorine atoms in such a way that the first fluorine is contributing 7 and the second one is contributing only 1 electron. As a result of which a bond is formed between them. So here in this particular case, since the second fluorine is contributing 1 electron to the first one is having 8 electrons in the outermost orbit. It means the octet configuration is achieved. At the same time, the second one is already having 7 in the outermost orbit and the first one is contributing 1. So as a result of which, even the second one will also have 8 electrons in the outermost orbit. So here in this particular case, a bond is formed between the two fluorines because each fluorine is contributing 1 electron. Each fluorine is contributing only 1 electron. So here, how do we define this particular single bond? So a bond which is formed between any two atoms by the sharing of one pair of electron, a bond which is formed by the sharing of one pair of electron, or else you can even say a bond which is formed by sharing of one electron each by each atom. 1 electron by each atom. So here in this particular case, each fluorine is contributing 1 electron. So here in this case, you can say that a bond is formed between the two fluorine atoms because each fluorine is contributing 1 electron. Now, since only one pair of electrons are involved in the bonding process, the bond that is formed is known as a single bond. The bond that is formed is known as a single bond. At the same time, the moment you talk about the case of your oxygen atomic number is 8 and its electronic configuration is 1s2, 2s2, at the same time 2p4. Now here in this particular case, the number of electrons that are present in the outermost orbit, they are equal to 6. And here in this case, oxygen requires 2 more electrons to gain the octet configuration. That is the reason why oxygen will try to form a bond with one more oxygen. Oxygen will try to form a bond with one more oxygen like this. So here in this particular case, each of these particular oxygens are having 6 electrons in the outermost orbit. So the first one will try to form a bond with the second oxygen atom. The first is already having 6 in the outermost orbit, and the second one is contributing 2 electrons. 6 plus 2, 8. So as a result, the first one is gaining the octet configuration. Similarly, the second one. The second one is already having 6, and then in that particular case, the first one is contributing 2. As a result of which, here in this particular case, even the second one is also having 8 electrons in the outermost orbit. So here in this particular case, how many electrons are involved in bonding process? Here in this particular case, 2 pairs of electrons are involved in the bonding process. 2 pairs of electrons are involved in the bonding process. So each oxygen atom is contributing 2 electrons. So that is the reason why the bond that is formed here is known as a double bond. A double bond is formed here. Why? Because 2 electrons are involved in the bonding process. So as a result of which, the bond that is formed is known as a double bond. At the same time, the moment you talk about the case of your nitrogen. So in case of nitrogen, atomic number is 7. Its electronic configuration 1s2, 2s2 as well as 2p3. The outermost orbit is having 5 electrons. It requires 3 more electrons for octet configuration. So nitrogen will form a bond with 1 more nitrogen. So nitrogen and this one. So here in this particular case, a bond is formed between them. So the moment here, the first one is having only 5. The moment the second one is contributing 3. So as a result, the first one will have 8 electrons in the outermost orbit. At the same time, the first one is already having 5 and the second one is contributing 3. Right. So first one is having 5, second one is contributing 3. So as a result, the first one will have 8 in the outermost orbit. At the same time, the second is already having 5, the first is contributing 3. So as a result of this, even the second one will also have 8 electrons in the outermost orbit. So as a result of this here, 3 pairs of electrons are shared here. So how many electrons? 3 pairs of electrons, or else you can even say each atom is contributing 3 electrons. Each atom is contributing 3 electrons so that a bond is formed between them. Now here, since 3 electrons are shared by each atom, or else you can even say since 3 pairs of electrons, since 3 pairs of electrons are involved in the bonding process, the bond that is formed is known as a triple bond. So if 3 pairs of electrons are involved in the bonding, you call it as a triple bond. If 2 pairs of electrons are involved in the bonding, you call it as a double bond. If only 1 pair of electron is involved in the bonding, then in that particular case, you call it as a single bond. Right? So based upon these particular bonds, you classify the organic compounds into saturated as well as unsaturated hydrocarbons. Right? So first we'll speak about the case of saturated hydrocarbons. So what are these particular saturated hydrocarbons? So saturated hydrocarbons are those particular organic compounds, are those particular hydrocarbons which consist of a single bond, between the carbons. So the moment you talk about the case of your carbon compounds, whatever is the length of that one. So in general, carbon compounds, they form long chain compounds. Carbon compounds, they form long chain compounds. And the ability of these particular carbon compounds, or else you can even say the process of formation of long chain compounds is known as catenation. The process of formation of long chain compounds is known as catenation. So of all the elements that are available in the periodic table, carbon will form long chain compounds very, very easily when compared to the others. Right? After carbon, you have got the case of your sulfur. Sulfur can form long chain compounds up to 16 atoms, only up to 16 atoms. But the moment you talk about the case of your carbon, it may go up to even 100 or even more than that one. And the ability of the carbon to form these particular long chain compounds is known as catenation. So in that particular long chain compounds, will be having only a single bond between the carbons. There is no question of double bond. Right? If it is only single bond, then in that particular case we call them as saturated hydrocarbons. And these particular saturated hydrocarbons, they are known as alkanes. Saturated hydrocarbons are known as alkanes. And any particular alkane that you take, right? So alkanes always end with the letters A and E. Alkanes always end with the letters A and E. That is the ending letters of the case of your alkenes. At the same time, alkanes are also known as paraffins. Alkanes are also known as paraffins. So the moment you're talking about the case of your alkanes,
ఇలాంటి మరిన్ని వీడియోల కోసం ఇప్పుడే డౌన్లోడ్ చేయండి ప్లాటో ఆన్లైన్ యాప్. యాప్ లింక్ కోసం డిస్క్రిప్షన్ లో చూడండి. ప్లాటో ఆన్లైన్ యాప్ మీ విజయానికి మీకు తోడుగా.
these particular alkanes have got a general formula. The general formula for alkanes is CnH2n plus 2. The general formula of alkanes is CnH2n plus 2. So here in this particular case, if at all you're taking n equal to 1, then in that particular case, the number of carbon compounds, if at all you see the structure of this one. Or else you can even say, the moment you're taking n equal to 1, then in that particular case, that particular hydrocarbon will be C1H4. When you're taking n equal to 1, the carbon compound is C1H4 or simply CH4. At the same time, the moment n equal to 2, then you write this one as C2H6. The moment you're writing n equal to 3, we write this one as C3H8. So n equal to 4, then in that particular case you can write this one as C4H10. Or else, the moment you're writing n equal to 5, then you can write this one as C5H12. So here in this particular case, whether you're talking about CH4 or C2H6 or C3H8, any particular hydrocarbon, or else in this particular case, right, out of the first 5, you have got only single bond between the carbons. And this particular CH4 is known as methane. CH4 is known as methane. At the same time, C2H6, this is known as ethane. C3H8, this is known as propane. C4H10, this is known as butane. And C5H12, that is known as pentane. C5H12, that is known as pentane. So the moment you're talking about the structure of CH4, right? So we said that only single bond is existing here. So how a single bond exists? That's what we'll have a look here. So in case of your CH4, we are having 1 carbon and 4 hydrogens. 1 carbon and 4 hydrogens. The moment you talk about the case of your carbon, atomic number is 6, electronic configuration is 1s2, 2s2 and then 2p4. Right? 2p2, sorry. 1s2, 2s2 and 2p2. So here in this particular case, the number of electrons which are present in the outermost orbit are 4. Carbon cannot lose 4 electrons, carbon cannot gain 4 electrons. That is the reason why it involves always in the sharing of electrons. And this particular carbon is trying to form a bond with 4 hydrogens. Right, in case of your hydrogen, you have got only 1 electron in the outermost orbit. Right, electronic configuration is 1s1. Hydrogen requires 1 more electron for stability. Carbon requires 4 more electrons for stability. So that is the reason why carbon is forming a bond. Carbon is forming a bond with 4 hydrogens. Right. So here you have got carbon, 1 hydrogen, 2 hydrogen, 3 hydrogen, at the same time 4 hydrogens. So here in this complete structure, you don't have any particular double bond here. Carbon is forming a bond with 4 hydrogens. That is the reason why you're calling it as an alkane, nothing but your methane. If you take the case of the second one, ethane, right? In case of your ethane, we have got how many carbons? 2 carbons. So 2 carbons are present. And these 2 carbons are bonded to how many hydrogens? 6 hydrogens. First, a bond is existing between them. Between the 2 carbons, we have a bond that is existing between them. So this is 1 hydrogen, 2 hydrogen, 3rd hydrogen, then the 4th hydrogen, 5th hydrogen, and then 6th hydrogen. So this is the structure of ethane. So you don't have any particular double bond here. Now similarly, if you talk about the case of your C3H8, so here in this case we have got 3 carbons. 3 carbons are present here. At the same time, how many hydrogens? 8 hydrogens. The first hydrogen, second hydrogen, third hydrogen, fourth, fifth, this is the sixth hydrogen, seventh hydrogen, as well as eighth hydrogen. Now here in this particular case, around each and every particular carbon, we are having 4 bonds, right? So if you count the number of bonds here, first one, second one, third, fourth. At the same time, even this one, first, second, third, fourth. At the same time, even this one, 1, 2, 3 and 4. Each and every particular carbon needs to have 4 bonds for sure, right? 4 bonds for sure. So that is the reason why here in this particular case, in case of your alkanes, you don't find any double bond or triple bond. You are finding only a single bond here. And carbon is bonded to either 2 hydrogens or 3 hydrogens or 4 hydrogens, but carbon will definitely have 4 bonds here. Then at the same time, the moment you are removing one hydrogen from alkane. Now for example, you are talking about the case of your methane. So in case of methane, what is the formula? Methane, it is CH4. At the same time, in case of ethane, that is C2H6. In case of propane, that is C3H8. Butane, that is C4H10. And pentane, that is C5H12. Now, when you remove one hydrogen, from all these particular alkanes, then in that particular case, we get CH3. At the same time, C2H5. At the same time, C3H7. So whenever we are removing one hydrogen from alkanes, right, C4H9 and then C5H11. But we know that each and every carbon requires 4 bonds for sure. For example, if you take the case of your CH4, we have got only 1 carbon but 3 hydrogens only. So carbon needs to have 4 bonds. So that is the reason why we draw a line here. Or else we are indicating a line here, indicating that this is nothing but a bond. A bond which is readily available for formation. Right? For each and every particular compound, you need to draw a line indicating that this is ready for the formation of bond. At the same time, this is short of 1 bond here. So this particular group, right? So this particular group which is obtained by the removal of one hydrogen. A group which is obtained by the removal of one particular hydrogen from alkane, that is known as alkyl group. A group that is formed by the removal of hydrogen from alkanes, that is known as alkyl group. So you call this particular one as methyl. CH3 is read as methyl. C2H5, this is read as ethyl, or else C3H7, it is known as propyl. This is known as butyl. At the same time, this is known as pentyl. Right. So any particular alkene from which you are removing hydrogen, that is referred as alkyl. Then at the same time, the moment you're talking about the case of the physical state of these particular alkenes. So alkenes in general, physical as well as the case of chemical properties. So alkenes in general, these are less reactive in nature. Alkenes in general are less reactive. But at the same time, alkenes are highly combustible, which means they are easily flammable in nature. Or else highly combustible in nature. They burn, they catch the fire very, very easily. Now that is the reason why we are saying that they are highly combustible in nature. So the basic properties, alkenes are less reactive. At the same time, they are highly combustible. Now since alkenes are highly combustible, the moment you're talking about the case of your LPG cylinder. So LPG cylinder, what does it consist of? LPG cylinder, it consists of butane gas. But here we have written one thing. Alkenes are highly combustible. At the same time, alkenes have got one more property. Alkenes are odorless. The physical properties of alkenes, they are less reactive in nature. They are highly combustible. At the same time, they are odorless. Now, these particular alkenes, which are highly combustible, they do not have any particular odor. Right? They do not have any particular smell. So LPG cylinder is consisting of what? LPG cylinder is consisting of butane. So the moment you are talking about the case of your butane, right? That is nothing but the case of your C4H10. It is highly combustible, but at the same time, it does not have any particular smell. But whenever we are using LPG cylinder at home, whenever you find some gas leakage, you get some smell. So what is that particular smell? From which chemical? Right? Why we are adding that one? The reason is that since alkanes are odorless, to identify the gas leakage, we need to add some chemical, or else it may explode. To avoid that particular explosion of LPG cylinder, we add some chemical. So what is the chemical that is added? The chemical that is added to identify the gas leakage in alkenes, or else particular in case of your butane, that is ethyl mercaptane. Ethyl mercaptane is added to identify the gas leakage. Ethyl mercaptane is added to LPG cylinders to identify the gas leakage. If at all ethyl mercaptane is not added, then in that particular case, the butane leakage or is the gas leakage will not be identified. So to avoid the explosion, we need to add some chemical, and that particular chemical is ethyl mercaptane.
ఇలాంటి మరిన్ని వీడియోల కోసం ఇప్పుడే డౌన్లోడ్ చేయండి ప్లాటో ఆన్లైన్ యాప్. యాప్ లింక్ కోసం డిస్క్రిప్షన్ లో చూడండి. ప్లాటో ఆన్లైన్ యాప్ మీ విజయానికి మీకు తోడుగా.
So in case of your LPG cylinders, butane gas is present in large quantity, or else you can even say the chief constituent, or else the chief component of LPG. The chief component of LPG is butane gas. And at the same time, the other gases that are present in case of your LPG cylinder, propane and isobutane. Propane and isobutane, even these two are present in small quantities. The large quantity, the one which is the chief component, the one which is present in large quantity, that is nothing but butane, which is the chief component of LPG cylinder. At the same time, what is the state of these particular things? The moment you're talking about the case of your organic compounds, or the case of particularly the case of your alkenes. Right? So alkenes up to 5 carbons. Up to 5 carbons. Right? It means that you are talking about CH4. From CH4 to C5H12. From CH4 to C5H12. All these particular things, they exist in the gaseous form. All these things, they exist in the gaseous form. At the same time, alkenes from 6 carbons to, right? Alkanes from 6 carbons to 9 carbons. From 6 carbons to 9 carbons. That is from C6H14 to C9H20. These particular things, they exist in the liquid state. And at the same time, alkenes 10 or more than 10 carbons. So any particular organic compound, any particular hydrocarbon which is having, or else any particular alkene in particular which is having 10 carbons or more than 10 carbons, that is C10H22 and beyond. So all these particular things, they exist in the solid form. So alkenes, they can exist in case of your solid, liquid, or as the case of your the gaseous form. And that particular thing, it depends upon the number of carbons which are present in that one. Up to 5 carbons, you say the gaseous form. 6 to 9, we say it is the liquid form. At the same time, 10 and more than 10, that exists in the solid form. Then at the same time, the moment you're talking about these particular alkanes in the day-to-day life, right? So for example, you're talking about the case of your methane gas. Where do you find this particular methane gas in day-to-day life? The moment you're talking about the case of your gobar gas, right? Gobar gas. So in case of your gobar gas, the chief constituent or else the chief component of gobar gas, is methane, and then followed by carbon dioxide, which means methane is present in large quantity. At the same time, carbon dioxide is present in small quantity. So in case of your gobar gas, the chief component is methane and then followed by carbon dioxide. At the same time, the foul smell that you get, the foul smell, the foul smell that we are getting from, right? The foul smell that is coming from wet or marshy lands, the foul smell that is coming out of wet or marshy lands. Now, these particular wet or marshy lands in general, we find them near to the equatorial region. The place, now that particular place which is very much close to the equatorial belt or else to the equatorial region, that particular region receives immense amount of rainfall. At the same time, in those particular regions, we experience rainfall almost each and every particular day. Now, since each and every particular day we are experiencing rainfall, the land in that particular areas, the land in that particular forest areas will be always wet enough. And it is because of the degradation of the plant leaves and the plants because of continuous rainfall, right? So the foul smell will be coming out of it, and that particular foul smell is because of the methane gas which is present in that one. At the same time, the foul smell that is coming out of your sewage, or as the case of your septic tanks, the foul smell that is coming out of your septic tanks, or as the case of your sewage, or as the case of your wet or marshy lands, it is because of the case of your methane gas. So, butane gas is used in case of your LPG cylinders. But whereas in case of your septic tank, or as the case of your sewage, or as the case of your wet or marshy lands, the foul smell that is because of methane gas. So on similar lines, the moment you're talking about the case of your washroom, so if at all washroom is not flushed properly, we all know that we get a foul smell. And that particular foul smell is because of ammonia. The foul smell that is coming out of washroom is because of ammonia, and the foul smell that is coming out of your sewage, that is because of the case of your methane, right? So this is about the case of your alkenes, nothing but the case of saturated hydrocarbons. Then moving on to the next one, that is the case of your unsaturated hydrocarbons. Unsaturated hydrocarbons. So these particular unsaturated hydrocarbons, you further classified them into two different categories. Unsaturated hydrocarbons are further classified into two different categories. What are they? They are known as alkenes. They are known as alkenes. At the same time, the other category of this one, it is known as alkynes. So what are these particular alkenes? Any particular unsaturated hydrocarbon consisting of double bond. Unsaturated hydrocarbon consisting of double bond, it is known as alkene. Unsaturated hydrocarbon consisting of triple bond, that is known as alkyne. So the moment you're talking about these particular alkenes, right? So first we'll speak about the case of your alkenes. Alkenes are those particular unsaturated hydrocarbons which consist of double bond between the carbons. At the same time, these particular alkenes, they are also known as olefins. And the general formula of these particular alkenes is CnH2n. That is a general formula of these particular alkenes. Now, the moment you are taking the value of n to be equal to 1, if you are taking n equal to 1, then in that particular case, it will be C1H2. The moment you are saying C1H2 here, it means that carbon is having only two bonds here. Hydrogen can contribute only one electron. Hydrogen cannot contribute two electrons. If at all hydrogen can contribute two electrons, then in that particular case, a double bond can exist here. But that is not possible. Hydrogen can contribute only one electron. So that is the reason why n equal to 1 does not exist. Because here in this particular case, the number of bonds for the carbon are not satisfied. That is the reason why n equal to 1 does not exist in case of alkenes. Then you take the case of n equal to 2. If you take n equal to 2, then in that particular case, you can write this one as C2H4. So here in this particular case, C2H4, if you see the structure of this one. So here you have got two carbons, and each carbon is bonded to how many hydrogens, right? So each carbon is bonded to two hydrogens, something like this. Now if you count the number of bonds for hydrogen here, if at all you count the number of bonds for carbon, so carbon requires 4 bonds, but if at all here in this particular case, the number of bonds that are available or else the number of bonds that are having carbon is only the case of your 3 bonds. So this is 1, this is 2 and this is 3. So carbon is having only 3 bonds here, but carbon requires how many bonds? 4 bonds. So as a result of which, carbon forms a double bond here. Each carbon is contributing 2 electrons. So as a result, a double bond is formed between the 2 carbons. So this type of your hydrocarbon is known as alkene. At the same time, the moment you take N equal to 3, you write this one as C3H6. So here in this particular case, C3H6 in the sense, this is known as propene. C2H4, this is known as ethene, or else this is also known as ethylene, or else ethylene. And then the moment you're talking about the case of your N equal to 3 here. So in case of your N equal to 3, you have got 3 carbons. We have got 3 carbons like this. At the same time, each carbon is bonded to totally how many hydrogens? Totally 6 hydrogens. Suppose that if you're having 1 hydrogen here, 2 hydrogen here, 3rd hydrogen here, 4th hydrogen, 5th hydrogen, and then 6th hydrogen here. But here in this particular case, carbon is having only 3 bonds. But carbon requires how many bonds? Carbon requires 4 bonds. So the moment you are placing a bond, a double bond, the moment you are placing a double bond between the 2 carbons, for example, here you are placing a double bond here. The moment you are placing a double bond between the 2 carbons, in this particular case, if you count the number of bonds for carbon, if you count the number of bonds for carbon, 2 here, 3, 4 and then 5. Right, at the same time, here we are having 5 bonds. At the same time, for the case of your first carbon, 2, 3 and 4. So here in this case, carbon is having 4 bonds, which is right. But whereas in the last one here, we are having only 3 bonds. Right, 1, 2 and 3. But carbon requires 4 bonds. So that is the reason why remove this particular hydrogen from here and then place this hydrogen here. So as a result of which here in this particular case, the second carbon is also having 4 bonds here. Right, at the same time the third one is also having 4 bonds. So here in this particular case, between the 2 carbons a double bond is exists. That is the reason why we call this one as an alkene. Right, at the same time, these particular alkenes, N equal to 3, C3H6, N equal to 4, C4H8, this is known as butene. At the same time, N equal to 5, that is C5H10, that is pentene. N equal to 5, C5H10, that is nothing but pentene. Then, the moment you're talking about the case of your alkenes, reactivity nature.
ఇలాంటి మరిన్ని వీడియోల కోసం ఇప్పుడే డౌన్లోడ్ చేయండి ప్లాటో ఆన్లైన్ యాప్. యాప్ లింక్ కోసం డిస్క్రిప్షన్ లో చూడండి. ప్లాటో ఆన్లైన్ యాప్ మీ విజయానికి మీకు తోడుగా.
So alkenes are more reactive. Compared to alkenes. So whenever you are comparing an alkane and alkene, alkenes are supposed to be more reactive. When compared to alkanes. At the same time, these particular alkenes, right, alkenes are used in the formation of long chain compounds. And in general, these particular long chain compounds, we find them in case of polymers. So alkenes are used in case of your long chain compounds, and that particular process or that particular phenomena is known as polymerization. Right, polymerization is one particular process wherein you are using these particular long chain compounds to have a different compound altogether, which are known as polymers. So the process of making these particular polymers with the help of the long chain compounds, that is known as polymerization. And alkenes are used in the making of polyvinyl chloride, PVC. Alkenes are used in the making of polyvinyl chloride, that is nothing but the case of PVC. At the same time, the moment you're talking about the case of your ethene or ethylene, right? The moment you're talking about the case of your ethene. So ethene or else the case of your ethylene, this is used in the ripening of fruits. Ethene or ethylene is used in the ripening of fruits. The moment you're talking about the case of your fruits, for example, as of now, this is the right season, you can say, the mangoes have started. So the moment you talk about the case of your mangoes, the green colored mangoes will turn out to be yellow colored mangoes. Right? Not on the trees. There are certain fruits which change their color on the tree itself. But the mangoes that we are eating, 99.99% of the mangoes that we are eating, or else the one that are available in the market. So all those particular mangoes, or else the case of your bananas, we are using some chemical so that the green colored banana or else the green colored mango is changing its color. We are feeling that the fruit is ripe, but the thing is that the fruits are forced to ripe with the help of some chemicals. So ethene or ethylene, it is used in the ripening of fruits. It is used in the ripening of fruits. Now already we have discussed this particular thing, ripening of fruits. Ripening of fruits is a permanent change. It is an example for the case of a chemical change. And we know that the chemical changes are permanent in nature. Once the color of the fruit changes from green to yellow, it is a permanent change. And in case of your chemical changes, you find a change in the mass of the substance. You find a change which is permanent in nature, which cannot be reversed at any particular point of time. Right? So ethene or ethylene is used in the ripening of fruits. At the same time, ethene or ethylene, right? Ethene, or else you can even say ethylene. Ethylene mixed with oxygen. It is used as anesthesia. It is used as anesthesia. It is used in the making of this particular anesthesia. So the moment you're talking about the case of your anesthesia, where do we use this particular anesthesia? So generally anesthesia is used during surgeries. Whenever a person is conducting a surgery, whenever a doctor is conducting surgery, then in that particular case, so in order to get rid of the pain at that particular point of time, the doctor will give some amount of anesthesia. Right? Then, what is the physical state of these particular alkenes? The moment you're talking about the case of your alkenes, right? Alkenes up to 3 carbons, 3 carbons in the sense, here you're talking about the case of C2H4 and at the same time C3H6. So these two, they exist in the gaseous form. At the same time, alkenes from 4 carbons to 13 carbons. Alkenes from 4 carbons to 13 carbons. That is from C4H8 to C13H26. All these particular alkenes, they exist in the liquid form. And alkenes more than 13 carbons, that is from C14H28 and above, all these particular things, they exist in the solid state. Right? So this is about the case of your alkenes and alkenes. So in the next class, in the next video, we'll be discussing about the case of unsaturated hydrocarbons, that is the case of your alkynes, and at the same time aromatic hydrocarbons, and at the same time homologous series. So what is homologous series? What are aromatic compounds? At the same time, what are alkynes? We'll be discussing that in the next class. Right? Thank you.